Okay, today we're going to talk about slope and rate of change. So slope is a ratio of our rise to run, or our change in y, divided by our change in x. Sometimes we say it's the vertical change divided by the horizontal change, which gives us to this formula, y2 minus y1, x2 minus x1. Those subscripts don't mean anything other than there's two different points. So if I had the point 5, 3 and the point -2, 1, this would be x1 and y1, and this would be x2 and y2. So all it does is delineate between the two different points. When I'm talking about rise over run, I want you to think of a staircase. So this is your rise. This is your run. And if you think about your graphs, this is your x-axis. So when we go this way, that's our change in x. When we go this way or this way, it's your change in y. Okay. Now you were introduced to this at the end of last year. So you should be sort of familiar with it. And you had to do some of this on your summer packet. Okay. Just like scatter plots, slopes can be either positive, negative, or neither. And we read them like we read a book. We go in this direction. So when I'm going in this direction, notice that this graph is rising. That makes it a positive relationship or a positive slope. Here, as I read in this direction, my graph is decreasing, so that's a negative slope. Now, these would be the neither case, and they're specific. This is a horizontal line, and its slope is a 0. Some people remember that because if you have the word 0, your horizontal lines are here and here. Okay, parallel lines on the Z be a 0 slope. When it's a vertical line, we say it's undefined or no slope. And notice that our parallel lines on these letters, if you can imagine that, are straight up and down. There's another little trick that I like that I saw and borrowed from the internet is our Mr. Slope guy. So we have this guy. He looks like this. He's kind of creepy looking, I know. But it can help you remember. Positive slope, negative slope. His nose, undefined, and his frowny there is horizontal, and it's a 0 slope. Okay. So I can find the slope from a graph. I can pick any 2 points, and you should pick lattice points. And what I mean by lattice points are points where you can see where your grid overlaps. Any kinds of points like that. Okay. And I draw a slope triangle underneath. So here is, what I mean by that is I can draw a right triangle. Okay. Now my rise over my run. So my rise is up and down, and my run is across. So I start at 1 point. So if I start here, and I'm going to go in this direction 3 places positive, because it's going to the right, and then I'm going to go up 2 places. Okay. So my rise is 2, and my run is 3. So my slope is 2/3, and we're going to leave it that way. Now, you could also, doesn't matter what point you pick because it's a ratio and it's not going to change. I could go here and draw my triangle above. Doesn't matter if you draw it above or beyond or below. If I go up 1, 2, 3, 4, there's positive 4. And I go right 1, 2, 3, 4, 5, 6, positive 6. My rise is 4, and my run is 6, which simplifies to also 2/3. So it doesn't matter what points you pick along those lines, they're always going to reduce to the same thing. So let's look at this example. If I pick these 2 points, and basically I look at it as following a map. If I start here, I'm going to go down 1, 2, 3. So I'm going down, and down in graphing is a -3. And over here, to get to the next point, a +1. So my rise is -3, and my run is +1. So my slope is -3. Now we can also use the formula, this y2 minus y1 over x2 minus x1. So if it helps, draw these over them just to help you. So y2 we say is 8 minus y1, which is 4, over 2 minus a -2. If I do that math, it's going to give me 8 minus 4 is 4, and 2 plus 2 is 4, so my slope is 1. Now it's not going to matter which one you pick to be your x1 or y1. So I could make this my x2 and my y2, and this my x1 and my y1. So then it would just be 4 minus 8 over -2 minus 2. So -4 over -4, which is 1. Okay. Next, let's try it again. So using our formula, x1, y1, x2, y2. Okay. I've got -1 minus a -2 over 3 minus 3, which this will give me +1 over 0. Whenever it's over 0, if you put that in a calculator, you're going to get an error, okay? Or it might explode because it's impossible. So 1 over 0 would give you us the undefined slope. So this is undefined, which makes sense. There's no change in your x values. If it was the other way around, if it was 0 over 1, then we would say it's 0. They're two totally different things, so you need to tell me what they are. Okay. So finding a point if I know the slope. So here's your extension from last year. We want to find the value of r so that the line that passes through each pair of points has the given slope. So we use m to represent slope. So using my formula, m equals y2 minus y1 over x2 minus x1. Okay. If I substitute in, okay, I'm going to get -8 for my slope equals here -8 minus -6 over x2 minus x1. Okay. This is just like a proportion. The -8 can be written as -8 over 1, and then this is plus. So remember, to solve a proportion, we're going to cross multiply. -8 plus 6 is -2, so I'm just going to put that there. And then I'm going to multiply here. Okay? So I'm going to get 1 times -2 equals -8 times 5 minus r. And now it becomes an equation, right? So -2 equals negative 40 plus 8r if I distribute. So I'm going to add 40 to both sides, and I'm going to get 38 equals 8r. And if I divide by 8, I'm just going to reduce that. So 38 eighths, 2 goes into both of those. So 19, that's an 8, sorry. So 19 fourths. Okay, so R equals 19 fourths. Now, slope in the real world is just called rate of change. Okay. So the rate of change is just slope in the real. So miles per hour, cost per movie ticket, all of those are examples of slope in the real world. And we usually put it down to one thing. So we're going to use the table here to find the rate of change. So all we have to do is look at the difference between our x's and our y's, right? So if I look at the difference here to here, so 156 minus 78 is 78. Okay, 234 minus 156 is also 78. And it's positive, we're increasing, and here we're increasing by 2. So my change in y would be 78. My change in x would be 2. So my rate of change, if I divide 78 by 2, is going to be 39. So it's in the real world, so we say $39 per ticket. And that's all rate of change is. If I'm looking at it in this graph, what's the rate of change from 1950 to 2000? So here's 1950 and here's 2000. Okay. You can also look at these as ordered pairs. In 1950, China's population was 0.55 billion. In 2000, it was 1.27 billion. And I can just use the formula then. So my 1.27 minus 0.55 over 2000 minus 1950. So 1.27 minus 5500 is 7200 over 50. And we don't like decimals, so we're going to just divide that out because we like it per. So we can either, it's 0.0144 billion per year. So China's population is increasing 1.0114 billion per year. So today we've looked at slope, finding it both graphically, algebraically, and relating it to the real world and calling it rate of change. If you have any questions, let me know in class, and have a mathtastic day.